Good afternoon, everybody. Welcome back after lunch. The first session after lunch, which is the technical session number 2. The first speaker for this session will be Mr. Anirban Aditya of Danieli, and the topic of his talk is adaptive process control in arc furnace. Mr. Mishra is back. As scheduled, the first speaker is Mr. Alok Kumar Mishra. The topic of SEME, his topic is Challenges with DR grade pelletization in India for Vertical Reactor. Just a brief introduction. He is a seasoned techno-commercial professional with over 13 years of extensive experience in the iron and steel sector, specializing in project execution, commissioning, and operations of iron ore crusher, beneficiation, pellet plants, DRI, and induction furnaces. He has a proven track record in leading end-to-end project delivery from flowsheet design and technology selection to commissioning at organizations like Jindal SAW Limited, Pacific Iron Manufacturing Limited. He is also certified in project management and TQM with core expertise in process optimization, equipment selection, project procurement, vendor management, etc. He is a hands-on technocrat with deep knowledge of mineral processing, green DRI, and R&D and plant operations. He is recognized for being diligent, methodical, and an effective team leader with a broad understanding of mechanical equipment and technical system. He is currently engaged in a most modern hydrogen plus natural gas-based green steel project through vertical shaft DRI and EAF route based in Oman as an AGM and project technical service. He is a core team member of ongoing decarbonization of rotary kiln project using hydrogen as a reductant. I welcome Mr. Mishra to come and give his presentation. So you have 12 minutes due to the paucity of time. At the 10 minutes time, I'll give you a gentle reminder. Mr. Mishra, please.
Thank you so much, sir. Good afternoon to everyone. Thanks to Steeltech and thanks to ECME for giving me opportunity to present a paper on the challenges with DR grade pelletization in India for the vertical reactor. It's exciting to stand here at a time when the world is talking about green steel and AI, and India has the opportunity to lead this transformation. As we know that the pellet is the backbone of the clean steel making, but the real challenge is not making a pellet, it's making a DR grade pellet which is suitable for the green DRI making or green HBI making in the vertical reactor. In my session, I will highlight the key challenges we face in DR grade pelletization and more importantly, the pathways to overcome them. So here is the summary of the DR grade pelletization, which should have the emissions around 150 kg CO2 emissions for the 1 ton of the green DRI or SBI. You know, we all are talking about the sustainable steel making or green steel, but you know, without a green iron or a green DRI, we can't make a sustainable steel or green steel. So this is the challenge India is facing currently. We don't have DR grade pellet currently in the India. The pellet we are producing, that is blast furnace grade pellet, which has Fe either 65 or below 65. We need 67% Fe in the DR grade pelletization, which is suitable for the green steel making through electric arc furnace route. And you know, in India we have a massive iron ore reserves, but we are not making DR grade pellets because that pellets are of low grade, that iron ore is of low grade. This is another challenge for India. You know, beneficiation pelletization and DR grade pellet will play a pivotal role in producing the high quality green DRI or SBI. So you can see in this graph that the world is producing around 600 million tons of the pellet currently, in which India has a massive share, around 20%, which is around 105 million ton of the pellet. So India shares a massive percentage in the pellet production, but these all pellets are blast furnace grade pellets, which has Fe around 67% or below 67%. In the second graph, you can see that the world is producing around 48 million tons of the DR grade pellet, but in India there is not any commercial scale plant that are producing DR grade pellet, so we are completely lagging in the DR grade pelletization in the India. So a question always arises to me when I talk to the Indian industry that we need to produce DR grade pellet. So people ask me that if we will produce the DR grade pellet and enhance our concentrate from 63 to 64% Fe to 67%, then our OPEX will rise. Definitely your OPEX will rise, but if you will upgrade your iron ore concentrate to 67% Fe, then you will get a pellet premium which hovers around 48 to $70 per ton of the pellet, and you can see the trend of the DR grade pellet in the worldwide, that is around $40 to $50 higher than current Indian pellet price. So I can say through this data I can say that using DR grade pelletization and producing DR grade pellet is an economical business too. So what are the DR grade pellets and what should be the quality of the DR grade pellets? So we need at least 67% Fe, which is most important, and we need a CCS around 280 or more than 280 to 300 kg per ton of the pellet, because that pellet will goes in the vertical shaft. That pellet will not goes in the rotary kiln DRI, which requires around 200 CCS per kg of the pellet. Your gangue should be less than 3.5%, and phosphorus and sulfur should be as low as possible. So what are the challenges with low grade iron ores in India? So in India, basically there is three types of ore. First is hematite, second is magnetite, and third is goethite. In the hematite, the impurities like silica, alumina, kaolinite, and gibbsite are associated in the very finer fraction of the iron ore, which is not easy to liberating easily if you will use the old technology. So we need advanced beneficiation to upgrade our hematite concentrate from 63 to 64% to 67%. We need advanced beneficiation technology like flotation and HGMS magnets. Current concentrate Fe of 64% is not suitable for making DR grade pellet by using hematite. So we need to upgrade it to 67%. For the magnetite, the magnetic susceptibility of magnetite iron ore is high. So it is easy to upgrade the magnetite iron ore to 68%. But the problem with the magnetite iron ore in India that this is very ultra low. The Fe in the iron ore is around 25 to 35%, and upgrading 25 to 35% Fe to 67, 68 is not easy. But in North India, in my past company, I was a core team member of this upgradation of magnetite iron ore from 25 to 68% Fe, and we have achieved that Fe in our trial and in our plant also. So I think for the magnetite, DR grade pelletization is possible. And the third is the goethite. So the problem with the goethite is the LOI is very high, around 8 to 12%. But if you will calcine this iron ore, then you can upgrade the Fe, which can be blended to the hematite or magnetite. So goethite in India, there is a common conception that goethite is of no use, but we think that goethite has a much more possibility to blend into hematite or magnetite, or we can calcine it and we can use it like the companies in Australia and China are using. Now coming back to the next slide. So what are the challenges with iron ore beneficiation capabilities in India? So the first is depletion of the high grade reserves and increasing impurities as we are mining, as we are excavating the iron ores day by day. Our Fe in the feed in the ROM is decreasing, and the impurities like silica and alumina are increasing. This is a major challenge for the Indian iron ore. So you can't expect a modern result by using the old technology. So we need to upgrade our beneficiation plants and technologies. We need to use high gradient magnetic separations, HGMS, and flotation cells. The second problem is higher waste generation with higher Fe. So the problem with India is the Fe in the tails is very high. We need to reduce it to enhance the yield of our iron ore concentrate, and we can reduce the OPEX also. The third is the technological infrastructural gap. We need more slurry pipelines to transport the slurry from mines to plant. That will reduce the CO2 emissions, and that will reduce the OPEX of the plant also. And the fourth is economic and policy gap. So in India, there is not a definite policy for the utilization of the low-grade iron ore in the plants. So we need a definite policy from the government of India for the low-grade beneficiation. Now coming back to the next slide, what are the best pelletization technology to produce the DR grade pellets, and what are the CO2 emissions? So if you will see, if you will compare the gas-based pelletization, then the CO2 emission for the 1 ton of the pellet is around 50 to 65%, 65 kg for the 1 ton of the pellet. And in the CO2 emissions, the state grade technology has an edge over the grade clean technologies. But if you will check the CO2 emissions for the Indian coal-based pelletization, then that is around 400% higher than this current CO2 emission on the gas-based pelletization. In India, by using coal gas, by using coal or syngas in the pelletization, we are increasing our CO2 emission is around 200 to 250 kg per ton of the pellet, which is very high. We need to work on it. And while both technologies are famous and using worldwidely, but great clean technology has an edge for the DR grade pelletization because of its better heat utilization and better quality consistency. Here is the difference between the grade clean technology and state grade technology. Now coming back to the next slide. So what are the green pellet and green DRI policy standards in India? So while Government of India has come up with the green hydrogen policy, green steel making, green steel star rating policy, we are expecting a green DRI and green pellet policy soon. The green pellet and green DRI framework policy shall expedite the India's green journey for the sustainable steel making. So this is the last slide. So what will be the way forward to produce the DR grade pellet by using the vertical reactors in India? So the first is we need investments in the low grade beneficiation. We need a massive, I can say that we need a massive investment in the low grade beneficiation. We need more modern equipment, more modern technology. We need Fe enhancement in our beneficiation. The second is the policy support to DR grade pelletization and vertical reactor. We need a favorable policy for the subsidy in the vertical reactor because the capex is very high compared to rotary kiln DRI. We need carbon credit for the vertical reactors. And the third is the R&D and tech collaboration. The R&D investment of the India is getting sinking day by day. So that is not good for the fate of the steel. So we need more fruitful R&D collaboration with the colleges, R&D government colleges and the industries. So this was my presentation. To sum up, I will say the road to DR grade pelletization suitable for the vertical reactor in India is not without challenge, but every challenge is an opportunity to innovate. If we align our resources, technology and vision, India will not just meet its demand, it will set a global benchmark in green steel making. The choice is ours and the time is now. Thank you so much for listening to me.
Thank you so much, Mr. Mishra. You really thrusted upon the importance of green pellets for green steel, especially DR grade pellets you mentioned.
Thank you so much.
And it was a very interesting talk. Thank you. So my next speaker of this afternoon session is Mr. Anirban Aditya. His topic of his presentation is Adaptive Process Control in Arc Furnaces. A brief introduction to him. He is an electrical engineer with an MBA degree with 25 years of experience in the field of electrical engineering and automation. He worked in Larsen & Toubro, Siemens, and at present attached with Danieli, India. So, Mr. Aditya, you have 12 minutes, please.
Thank you very much, Professor Das, for the nice introduction. I am representing Danieli. Danieli is having more than 100 years of presence in metal industries, and with this we have acquired many technologies. Danieli Automation is the company which integrates all the different parts of Danieli as a whole, different technologies through its superior automation as well as electrical solutions. So today's topic that I will broadly cover upon is adaptive process control in electrical arc furnace, and also in which I will also take a topic which is called DG melter, a patented technology from Danieli towards the sustainability of steel making. So going forward, road to decarbonization. In Danieli, we believe in going for net carbon zero. So for that we are committed. We have this roadmap of starting with reducing energy intensity by 20% with the superior innovations that we have made, and reduce the greenhouse gas emissions intensity by 50%, and accordingly within FY45 we are committed to come into a complete net zero of steel making. And with this we also have different partners like Tata Steel, Algoma, in US we have ArcelorMittal as well as Liberty Steel. Likewise there are many companies who are patronizing us, and they are also coming forward. So the benefits of DG melter. What is DG melter? We call it quality 1 in short. It is Q1. What it does is it gives the power to the arc furnace through a huge MV drive. It is very difficult for you to conceive it, but yes, it has made into reality. Now what we do is the entire operations are controlled by the drives. So this way we can control the current, we can control the voltage and also the frequency. So the decarbonization path will increase the use of electrical arc furnace for steel making challenges. How? It has flexibility in operation. Also, it's very easy to maintain because these are all modular, and low dependence from electrical network. So wherever you have weak network, like for example in Bangladesh and rural parts of India where the plants are set up, the grid strength is not much. So there, if someone wants to really put an arc furnace, it is not possible for them because of the weak grid. But with the help of Q1 DG melter, we will be able to do that. Also, it is a clean energy only because there is no harmonics pollution, that it encourages also high power factor and various other benefits that it gives. I will discuss it in my subsequent slides. And also it has quite a good amount of energy saving. That is about 5 to 7% of energy saving it happens compared to the conventional use of arc furnace control technology. Now this is how it looks like. On the right hand side you see the dirty bus where the arcing takes place, and you know there are more harmonic pollution within the this circuit. But when you go on the left side of the DC link capacitor, there it is completely clean power. Why? Because we use you know 18 pulse transformer. A different you know design has been made for that, suitable for Q1, and this ensures that the power is clean from the supply side, that is from the grid. So the flicker is extremely low. It is unbelievable when you all know that arc furnace operates. There are always huge flickers and lot of noise. So once an arc furnace operates with our latest Q1, there will be almost you know noiseless operation, as well as you know the flicker will be absolutely low. The power factor is guaranteed close to 0.97. If you use SVCs, then it can also you know go to 0.99 or unity, near unity power factor. Harmonic distortion I have already said, and also voltage unbalance. It takes care of voltage unbalance. It balances out the energy in 3 electrodes in a AC arc furnace. So this is how it looks like. So when you are using Q1, you don't have to use the conventional furnace duty transformer. It also does away with the series reactor. Also, you know, you don't have to use various other circuitries which are normally used in conventional arc furnaces. So here the main transformer, then the Q1, that is the MV drive that controls everything, and you know you have the other circuitries. Now once you want to use the renewable energy, suppose your grid is not so strong, so you can also use wind power or else the solar power, and you can put it into the DC bus, high voltage DC bus, and the arc furnace operates with hybrid form. Now with this I am shifting it towards you know the automatic EAF concept. This has balance of a proper regulation. A melt model is there which gives you you know dynamic setup, and it also integrates all the variables in the arc furnaces. So going forward, it boosts the productivity, how that I will discuss in the next slide, and also it reduces operational cost, that is the OPEX. So it's a complete closed loop control, and the chemical package that enables the dynamic adjustment of the furnace profiles. So this particular slide explains it all. The inputs are like oxygen flow, the temperature probes, then the QREC Plus, that is our regulation software, which is a digitalized regulation software. Then the Q charge, that is the scrap mix. So you are using different scrap mix. So how to use it effectively, everything is controlled by the intelligent package, which is referred here as fingerprint. And also the steel chemical composition and slag composition. So all these are taken into consideration. And finally the melt model controls the different variables and tries to give you optimized way of production of steel. So the melt model compares the real-time readings with the fingerprint which I have just explained, and adjust the process parameters as well as everything together in that model. When the off-gas analysis is done, the percentage of CO or CO2 is more, then accordingly the oxygen injection is regulated through the software. So we call it a soft landing melt model because when it is used, it also gives a function for real-time decarburation control during refining phase. Then also integrates information from electrode regulator, then the chemical package. It also takes care of the off-gas analysis and then integrates into the model. Expected process behavior is stored in the fingerprint, and from there the melt model operates and gives the output. So mainly these variables of temperature, carbon and oxygen trackers, those are all integrated with the help of the melt model in level 2, and it gives you a proper steel quality in a very efficient form. So what are the benefits? If I sum up, reduced consumption of electricity, electrodes and chemical inputs like oxygen, carbon, natural gas, etc. Faster tap-to-tap time, enhanced safety and process flexibility for handling various raw materials. So if you want to really quantify and want to see that what are the used cases, the case studies. So we also have those details in this forum. I am not stretching it long. Thank you very much for your attention. We are committed to the sustainable and efficient way of steel making. So with this, I end my presentation. Thank you very much. Thanks.
Thank you, Mr. Aditya. You have given an excellent lecture, or talk rather, on adaptive process control in conventional arc furnaces and how to make it a smarter one and less polluting one. And it was brief, but it was very thought-provoking and lot to take home and discuss about it. Thank you very much. The last talk of this session, Logistics for Sustainable and Cost-Effective Steelmaking, by Mr. Pravin Saraf of TMILL. A brief introduction of him. Mr. Saraf has been a part of Tata Steel Group since 2002 and is currently leading the Railway Logistic Division of TMILL, a position he took in August 2024. He began his career as a divisional accountant at TMILL in 2002 and over the years has worked in various roles including managing large projects, leading a profit center till 2017 before transitioning to Tata Steel. At Tata Steel, he focused on portfolio management and later shipping and logistics operation for 7 years before returning back to TMILL in 2024. He now heads the railway logistics vertical, which operates more than 100 private rakes and serves various companies belonging to steel and cement sector. Throughout his career, he has driven notable improvements across all departments he has worked in and is currently leading the transformational journeys of TMILL Railway Division. So, Mr. Saraf, please.
We had very good technical sessions. We started with DR grade pellet, which is like food. We had DG melter and G melt, which is like organs of the body, and what I'm going to talk about is very different, which is like blood circulatory system of human body. It's all about logistics. Very different topic, but yes, for a cost-effective and sustainable steel making, logistics plays an important role, and that's why I chose this topic. Why logistics is important when we talk about sustainable steel making is because if you look at this logistics map and if you look there's so much of footprint that is covered by both inbound and outbound materials. And 1 ton of finished goods requires 4 ton of movement. While 4 ton of movement only moves between plant, means what is coming in, what is coming out. But in the overall space, it is handled multiple times. And I don't have that number immediately, but that will be more than 7x kind of thing. And as far as cost is concerned, we have various reports ranging from 11% to 28% of steel making. So 28% when we compare it with regard to cost of production of steel, around 15 to 18% if we look from revenue point of view. So logistics plays an important role in steel making, and it is important that we also find very cost effective and sustainable means of logistics when we plan our supply chain. Now going to the very basics of logistics, when we talk about logistics in steel making, 3 modes comes to our mind very clearly: a sea route, rail route, and road route. And from sustainable point of view, if you look at the left side of the graph, it's very clear that sea route is more sustainable, more cost effective. And yeah, this is the general, I would say, general knowledge that we carry. But when we move to the domestic part of movement, and especially on Indian context, when we see that our plant and destinations are not very well connected with our origin and destination or consumption points, and if we do a complete working of our CO2 emission in the entire supply chain of outbound, and since India is a peninsula, so for moving from east to west, you need to go to south and then come back. So I did a calculation that for covering from Orissa to a place in Maharashtra, you have to cover 1300 kilometers if you go by road or rail. But if you go by sea, in adding, and if you add the first leg and last leg movement, you have to move 2 times. It is close to 2700 kilometers. 4000 kilometers. 2700 kilometers is only the sea route movement. So this is the kind of distance you have to cover if we look at sea route, and then if you calculate the total carbon emission in the entire supply chain, then rail becomes the lowest emitting or more greener mode of transportation, followed by coastal. If we look at 25,000 ton vessel, there are challenges with the kind of cargo aggregation you have to do, the long lead of deliveries, and the multiple handling, of course, which is not there in the rail or road. And if you have to consider a smaller parcel size of about 5,000 KT, then rail and coastal becomes more, means coastal is about 31 kilogram per ton versus rail of 16 kilograms, almost 2x. But if there is a straight line connection, like if I have to go from east within the same coast from north to south, then rail is at par with the coastal mode. So we also do in TMLL, we also do inland waterways movement of finished goods. So we use this IBP route, Indo-Bangladesh Protocol route, to go to northeast regions. So there also we ran a calculation, and we saw that rail mode is more greener than the waterways. So these are some fact-based, I would say, fact-based our understanding that rail is greener, and if you do cost calculations also, always we find it very challenging to match the rail cost when we do a alternative mode calculation while coastal and others. But then what is the challenge? Challenge is rail capacity is not unlimited. It's very constrained. And if you look at India's last 5-year data, The steel capacity or steel production from 2019 to 2024 grew by 50%, almost 50%. And the rail traffic moved by only 14%. In the morning, we heard from Mr. Somesh Biswas of Tata Steel that India plans to have a 500 million ton of steel making by 2047, which means a growth rate of 5.5% per annum CAGR from today. And if we see the past data, how our rail is growing, rail is hardly growing at 2%. So there is a capacity constraint in rail network which is forcing the steel industries to move through alternate modes, and the easiest alternate mode is by road, which of course is more costly and not environmental friendly. And that's why there is where we start playing on the coastal and inland waterways and those kind of opportunities. So one of the capacity constraint in rail network is with regard to having rake availability. And rake availability for steel, if we look at FG side, these are specialized wagons, which generally is not available in the railway system. In TMIL, we are the largest in India in private rake operations in non-container category. So we operate 108 private rakes, which is divided 50-50 between rakes for steel cargo and rakes for raw material. So we operate 53 box NHL rakes meant for raw materials and 55 specialized freight trains, BFNS, BFNSM, BFNV, this kind of rakes. And this, while we operate so many rakes, what we are facing now, the challenge is that half of the time my rake is actually not moving, which is stranded at some point in the rake network because of want of path, crew is not available, loco is not available. So yes, while we can fix the issue of capacity by having private rakes, then railway also need to augment its capacity by augmenting the overall capacity of railway network, which railway definitely have their plans. But important point is that rail is cheaper and greener. And one more point I want to deliberate here. Currently, if you have seen my first slide, railway is emitting about 8.7 grams per ton kilometer. That is the emission factor. And entire emission factor is dependent on grid supply. And carbon efficiency of grid is about 71 gram as of today per kilowatt, which over time the government of India has planned to bring it down to about 40.4. So they are going to reduce their carbon emission factor by about 40% over time. So rail is going to become more cheap, more greener. And so this is the most effective and sustainable modes of transportation that we have to look at when we look at domestic movements in the country. So we need to invest more on the rail capacity, both on the front of rolling stocks, which is this where we are, and as well as rail capacity, which the government has taken a lot of initiatives. But in our railway system, we also use a lot of digital tools. We have our own systems. We call it LOB. We have our tracking systems. We have regular latest information along with its trends, how the entire journey has happened. We also use robotic automatic processing. So we have AI also. The data is automatically captured The railway receipts are received automatically by our robots. They do data reading, they put it in our system, they match it to the respective trip, and they do lot of commercial documentation and other things. So this is where, because this today's conference was also meant on AI and digital, so I thought that I bring that flavor also, how we use this kind of technologies in our logistics operations. It's not only railways where we do all this. We, as TMILL, just to introduce, we have wide bouquet of services, mostly centered in steel making, steel industry. We are in ports. Historically, we do custom clearance inland logistics. We provide intermediate warehousing facility both for project movements. So whenever the capacity augmentation is happening, all the project materials we do manage, including warehousing as well as last mile logistics. We do manage the warehousing of consumables and MRO items. We have a freight forwarding arm with global presence. We specialize in handling urgent shipments. So we have also arranged shipments in hours from China to the project site. So this is all about TMILL, and thank you. Thank you for patiently listening. Thank you.
Thank you, Mr. Saraf. It's a very interesting talk on cost-effective logistic options, not only for the steel industries, or any large industries that can be effectively used. Now we have time for a couple of questions for these distinguished speakers from the floor. Anybody has any question? If not, then I thank all of you for a wonderful afternoon and giving very insightful lectures in a brief time period. That's very important. Oh.
Yeah, so first leg and last leg movements. So like I took from Kalinganagar to Boiser, which is our regular movement for Tata Steel. And so from Kalinganagar to say Dhamra Port, then we go to JNPT, and then we go to Boiser. So combined overall on kilometer terms, it comes to around 4,000 kilometers. So 2,700 nautical miles, which translates to close to 3,000, in factor of 1.85. So it will be close to 3,700 kilometer is the sea route. And then we add around 125 kilometers first leg, and then another additional. Yeah, so it crosses 4,000 kilometer. So 2,700 was nautical mile, not kilometer. Yeah, so dedicated freight corridor is already operational. In the eastern part, we do use dedicated freight corridors for going to Ghaziabad, Faridabad, all of that. So we connect to nearest dedicated freight corridor in, I think, Odisha itself, and then I think Jharkhand or Bihar, and then we go up to north. So it actually has given immense benefit in terms of turnaround time. So earlier, we used to travel close to, even on an average, we do about 250 to 300 kilometer a day. But in dedicated freight corridor, we are able to travel 3 times a day. So that's the benefit.
Thank you.
Yes, yes. So somewhere nearer to the destination, then we come out to the regular route. So I'll give you more details of the dance.
Thank you very much, Professor Das, and 3 excellent speakers, Pravin, Alok, and Aditya. It's a big round of applause for this excellent presentation and the conducting. May I request for a group photo, please? And now may I request Mr. John Chatterjee to kindly come little forward here. You do the honor. Thank you very much. We are now in the third session. So in third session, there are two papers. And the chairman of the session is Professor Rajiv De, Professor of Jadavpur University. May I request Rajiv? Rajiv is already here. Rajiv, yeah, he's there. And Madam Riti Chatterjee, although she is suffering from high fever, she has come all the way. And her group is there, Polomi and Akash. And another last presentation will be by Sujit Sengupta. He is in Canada. He will do it online. May I now request Madam Riti Chatterjee to come up to the stage. And also, yeah, Professor Rajiv is already there.
Hello. Good afternoon, everybody. So basically, this is the last session of this particular day, particular seminar. And we have gone through different types of lectures throughout the day. So in the last session, this is technical session 3, there will be two papers. One paper will be given by Mrs. Riti Chatterjee. The topic is microimaging from concepts to implementation, the economic way. And the another session, the another topic is AI-driven maintenance and optimization in mining and steelmaking, and it will be given by Mr. Sujit Sengupta, but hopefully that will be given in online. So without wasting time, I request Ms. Riti Chatterjee, Lumule Research. I have heard her before also. She is an excellent speaker, and so I request Didi. So please start the lecture. And I don't know the time it is given is half an hour. Whether it will be half an hour or 15 minutes, I don't know. 15 minutes. Okay, okay, that is, yes, because I have seen the timing and I was a bit astonished. Okay, okay, so it will be 15 minutes. So the lecture will be given by Ms. Riti Chatterjee.
So the topic today is... ঠিক আছে. Am I audible? I thought my voice was so sonorous that everyone can hear without the mic also, right? Oh, okay. Great, great, great. Thank you. Thank you, Pratista. So this is something which is, what we have stumbled upon very recently. Plumule Research is actually engaged into doing such projects that are challenging and that are on the ground challenging. We try to solve the problems with technology, very site adaptive, very much working on the ground, on the field, and innovating there itself. So you'll see us in the, across the train lines and programming there also. On the platform programming there, at the sinter plant, just beside the sinter plant bed and programming there. So it's a challenge, and it's a kind of different type of joy that we have here, and this is one of the things we stumbled upon in one of such exercises. And yeah, this actually gives a bit of a background about us, about the projects that we did. We are still a startup. Our vision is actually to grow innovation in the next generation students, and we really look at being able to build sustainable product development and sustainable steel industry. We are focused on the steel industry in a very secure manner also, so that, and focus on industrial innovation. So these are the key words for us. So this is what, we have brought the product here. This is what we want to present today. We have codenamed it MicroCam, okay? So it helps us get very deep structural imaging, microscopic imaging of the, any material, whether it's dolomite or a sinter or a limestone or urea. It helps us understand the material which you cannot normally understand from the visual, just visual aspects. So that's what we are doing, and we are looking at use of it, of the same concept on high-speed conveyors, so that we can afford a very low cost and a very sustainable way of material characterization, material classification that is very much necessary, and understanding the quality in line as the process is happening, and being able to take corrective action then and there. We thought this process was very important. You know why? Because as if the process for quality takes more time than the process for production, then what is the benefit? I have no time to correct. So we looked at this as the opportunity in which Plumule should be able to give some solution. And we are still starting, but I just wanted to share where we are, and I will welcome everyone's inputs here to help us grow. So the solution is very simple. We have our MicroCam, kind of photographic solution. It's a computer vision solution. And then the platform which does the exploratory analysis also, both supervised, unsupervised, whatever is needed, and then gets the output. So if you can see, this is a preliminary view of, we started with this very, raw versions of dolomite limestone looking almost the same on the conveyor belt. But then when we put a camera there, we see the stark difference, right? See? This one? You can see the rhombohedral crystals, right? See? Massive crystals, right? Very strong dolomite, very stable dolomite, chemically stable dolomite, right? Right? So this visual observation was, it's very, from the picture, when we do through the micro camera, we understand that this is a very good formation of rhombohedral crystals, very strong calcium, magnesium, carbonate crystals with not too much of calcium carbonate interfaces. There are some colored differences, colored impregnations, which are showing that iron, magnesium impurities could be there. But still it shows overall a very stable one. And if you really look at it, so of course all the properties are talked about here. And bigger rhombohedral crystals that we had in our sample, we can also go for smaller rhombohedral crystals. They are not stable, they're not chemically stable, they will be very reactive. But bigger rhombohedral crystals are very chemically stable, and the purpose is definitely different. How much we put in the blast furnace, how much we put in the sinter, It is all dependent upon the type of the dolomite we have, right? Very carefully and very fine-tuned control of the productivity of the entire process. Now let's look at limestone. You can see grains, completely different. Fine grains, right? It will get powdery, it will just break off, right? This is limestone, right? Again, limestone. You can see yellow patches, right? Yellow patches, right? Yellow patches. Okay, so fine-grained are microcrystalline structures. You can also get rhomboids here, but they are fine-grained, right? And these are called calcites, micrite or microcrystalline calcite. That is the short form of it, right? And very high pure calcium carbonate is shown here, okay? And of course, so there is a, yes, presence of yellowish is because of ferrous impurity, iron Fe2 plus ore actually. So impurity is partial oxidation is also trapped here, that is shown. And then, surface alterations can happen. Those all things can be deduced based on the model. So we actually take the picture, we classify the picture, and then we can use that for inline monitoring. That is the process. Same thing we had applied it to sinter quite some time ago, and we were able to understand this. But that time we were not using the microcam, we were doing completely with the CNN and AI, but now it becomes much more easier with the new microcam that we have introduced. And we should be able to characterize the sinter. We do not need to wait for the lab reports to come. We can do it just when it's coming out of the cooling mechanism and it's coming onto the belt for carrying to the blast furnace. There itself we can do it. And we can give the feedback immediately. So while these are true, I'll quickly go through this. So these are the points that we wanted to, kind of tell why it is economic. Because if you really look at such analysis mechanisms, one is the lab analysis. It's not effective in controlling the process, very clearly. If we want to do online, the cost will be 25 lakhs plus, and if you're going for XRD and all, it's in terms of crores, right? So a microcam can be deployed from 2 lakhs to 6 lakhs. Within that, we can deploy it. We can go down in cost to that extent, and I hope with time, things will become better, because we are looking at integration of other technologies, not just light wave, but also be able to use radar waves, microwaves, sound waves, bring them all together and study the material. So that's the next step that we are looking at. And you get a payback in less than 6 months. So, and with this, I come to my end, and we have several of you here who are great SMEs from the steel manufacturing. We are looking for a very strong collaboration, and we request Steel Tech to help us with that. If we can form a very collaborative team to take this mechanism. And this is the way we can do for what is already existing. We cannot throw our blast furnaces out. We have built them with care for so long. So how can we make them greener? By very fine-tuned control. And this is one of the mechanisms for it. Thank you.
Thank you, Ms. Riti Chatterjee.
Any question? We are yet to do that. We want to do that, sir. Yes, sir, yes. We know that, and we are eagerly looking forward to more collaboration to grow this. And the purpose of using this opportunity to speak to all is to get those requirements.
Yeah, you can ask startup people to give you some sample of pyroxenite and dunite and find out and do some investigation on that also.
Yes.
They're regularly using it.
Yes, sir.
Okay.
Yes, we want to, you have told me about Donite earlier also.
Yeah.
We want to do that also and understand the different benefits of doing it. Means how will inline help in decision making, faster decision making and better
Or we
productivity.
can get it in any other mines also. There are plenty of such mines.
Yes. So we are also looking at doing something else. Let me just tell, prediction, silicon prediction, and I have heard that this model typically doesn't work. Okay, one thing I believe which could lead to models not working is not accurately representing the dynamic
Recording
situation.
stopped.
Okay, so dynamic situation, if it is not representing actually, then you cannot do right prediction of the silicon content, right? So we are looking at being able to use more dynamic way, more online sensors, whatever it's capturing, involve that in the model directly, online itself. And that's physics informed neural networks. That's what we are looking at applying for this.
I have one,
Any more question?
I have
Any
one
question?
quick question.
Sure, sure.
The macro structure, rather, you showed of big ores. And you are correlating with that things with textures and the minerals present, how it will be reacting. But generally for minerals, they do thin section to find out identify the constituents of that minerals and their texture. Do you think this macro photography can give the same results as thin section analysis?
It will not quantitatively give, it can give qualitatively.
So without any mineralogical study, so you
Correct.
have to have a pole microscope to identify the minerals. You took a macro structure which does not have polarized light. So how will you identify what is the mineral present in your, what are the different minerals present in that?
Exactly. So basically this entire thing about AI is inferring based on characterization, based on classification, right? So if we can compare and if we can allow different diverse samples to be analyzed and classify that this is this, then it should be able to tell this is the nearest, right? The only thing that we are doing is we are making it more detailed picture than the normal vision, right? We are taking a more detailed picture and characterizing it. This is not the only thing. Let's look at every chemical property has a physical behavior outside. Okay, so we are not only looking at the light as the only mechanism, we are looking at other mechanisms also. Like we are looking at radar, we are looking at microwave, we are looking at also sound waves and looking at how the scattering is happening, how the reflections are happening, and from there we are able to get the understanding. For example, so it depends upon the properties that we can inline detect and what are the mechanisms. So let us not just restrict to this. This is just the start of it. There's a lot more to do, and I'm sure it's possible because every chemical property also leads to a physical property.
This was my question also, as Professor Das was telling, because sometimes when without doing the X-ray diffraction, so by seeing only from the macro imaging or say with respect to XRD, I am telling, so sometimes different minerals can seen in a similar way, similar pattern can be seen. So how we can distinguish between those things? So that was Siddhartha's question, that was my question also. That is the point.
So
Anyway.
yes, I'm not telling it this is infinitely possible, but I'm definitely telling that it is possible to certain extent to diagnose, and we have to probably refine furthermore. For example, in the initial part, we were seeing that urea we are not able to understand at all. We were not able to. But then with controlling the lighting mechanism, then with controlling the mechanism by which we are understanding, like use of microwave to be able to understand the change in the density deep below. This was a question also. So underneath what it is? With light you are able to see what is on the top, how do you see what is underneath? So the properties are electronic properties, electronic configurational properties, how it changes it also has an impact that we should be able to understand. Now, it is not very easy, let me tell. We have to go to the first principles to design this thing, to be able to understand the differences. How the waves will be scattered, how the waves will be reflected. If I put in polychromatic, how it will be done. See, polychromatic, all those different mechanisms of lighting, that will also help me understand the calculations, okay? So it is not that it is not possible, it is possible. Only thing we have to understand, go from the basics, the first principles.
Definitely. Thank you, Ms. Chatterjee, because our next speaker, Mr. Sujit Sengupta, is also waiting. So I think, actually, Orgo, actually, Mr. Sengupta is waiting. So can we take the question after his lecture? Okay. So thank you. Thank you, Ms. Chatterjee. I think we should give a big round of applause to her. So the last speaker, he will speak in online. The topic is AI-driven maintenance and optimization in mining and steelmaking. The speaker is Mr. Sujit Sengupta from Admira. He is residing in USA and Canada, something like that. So, Mr. Shen.
Hello, can you hear me?
Just 1 minute, Mr. Sengupta, let me introduce you. Mr. Sengupta, a big thing. He is a practicing accredited professional engineer in Canada, a climate change expert with experience and credentials to underpin expertise to make the difference. And he has worked in different areas, and he's aimed to address the issues like energy efficiency, reduction of emissions and pollution, decarbonization of the economy, electrification of energy usage, making society more equal and making everyone a part and contributor to the solution, adoption of clean water technology. So more or less, he has worked a lot for sustainability. So I think you can start, Mr. Sengupta.
Hello, good afternoon. Can you hear me?
Yeah, it is audible. We can hear you.
Okay, thank you.
Yeah, loud and
thank
clear.
you very much.
Loud and clear, Sujit, yeah.
Yeah, thank you very much. The previous presentation was very interesting, and I will deviate a little bit to say that it has a lot of applications in mining, especially in sizing the ore and finding out the scrap in the ore, because the scrap creates a lot of problem in the crushers and the toggles in mining. So, and this has a safety aspect also, Ms. Chatterjee, that how do you make the operation safe by removing scrap? So this is just my point of view when I heard your lecture. It is very good. So to introduce myself, I work in the AI, automation, as well as electrification and other areas. And I work with large projects, large infrastructure projects. And I'll just share my screen. Share my screen. And I will go to my first screen. Share. Then I'll go to PowerPoint. Just give me a minute. So you can see my screen?
Yes, yes.
Yeah. So I am the owner, CEO of Admira Distributed Hybrid Energy Systems, Inc. We work in California and Canada and various jurisdictions of Canada. And we do a lot of mining, electrification. We worked with Vale in northern Canada. And we also do a lot of light rail transit and infrastructure projects. That's what we do. At the moment, we are commissioning two very important projects. As you know, Los Angeles is going to have the Olympics, next Olympics, and we are commissioning an automated train, a people mover, in Los Angeles City and airport, as well as we are commissioning a hydrogen train in California, which is called Zimu. So that's the background. So basically mining, steelmaking, I worked in Tata Steel as well as in ONGC in India. So, and studied in Kharagpur. So this presentation is dedicated to my teachers and mentors that I had in India, in IIT, as well as the people I worked with in Tata Steel and ONGC. So going ahead with the presentation. So Admira is a research-focused technology committee committed to the use of green energy and cryogenics technologies. And we are looking at it from the lens of applying AI across industries. So as we know that steel and other mining and steel industry is very challenging to decarbonize. So it is difficult to decarbonize. So these are the industries that we work in: transportation, mining, and refining. And we bring in some expertise in terms of surveillance and auditing capabilities, safety and risk assessment, and hydrogen and oxygen construction projects. So this is where I was trying to suggest that the previous speaker, Ms. Chatterjee's presentation, would be very applicable in EPC surveillance, and especially in safety in terms of mining and haulage and crushers and sizing of ore and picking up scrap from the ore. So basically, when we apply AI, we have to look for quick wins. So basically, you had a very good presentation day here in Kolkata, and you talked about digital twins and predictive analytics and uptime and quality and GenAI. So this is just to summarize that AI should be applied in pilots and projects around 12 to 24 months. We start with digital twins, put in predictive analytics, uptime and quality effects, and then generative AI also uses natural language processing, which is very helpful in terms of using legacy systems, reporting structures, and for example, the shift reports and the SOPs, and helping them normalizing the data, cleaning the data, sanitizing the data, and using it for decision support on a large scale. So in mining, where I used to work, mining and smelting in northern Canada, we have seen improvements in availability, failures, maintenance costs. We'll talk in a minute about the various trucks, haulage trucks electric trucks, where we applied it. And then it also improves in yield in terms of the smelter and processing, and it reduces energy by optimizing the processes. So going to the next slide. So we have, from our experience of working with various industries, seen that downtime can be decreased, maintenance costs can be decreased. And we worked with the first electric trucks in the world in the Kiruna mine in Sweden, as well as the Coleman mine in Canada. And we could have very high availability figures. And using AI and predictive analytics, we were able to reach an availability and utilization figure of around 90% or so. And this was corroborated by a published paper from Volvo, which they said that they were able to reduce downtime by 30% and cost by 25%. But the Corona truck availability project, which we will discuss a little bit in the presentation, really showed us the way that how first predictive analytics and then AI helping predictive analysis could make a very substantial improvement in the tonnage as well production, as well as availability and utilization, and also safety. So since I also worked in ESG and safety, predictive monitoring and AI has a big effect in terms of monitoring incidents and reducing incidents in a mine. And the clearer we are with the safety processes, the detection and follow-up and the RCAs and the root causes, we are able to analyze, reduce the safety incidents. And we saw in the mine, in Corona mine, in the Coleman mine, that we could reduce incidents by around 40%. The base of the incidents is reduced, but the occurrence of incidents decreases. Then we have to create, as for all AI projects, we have to create a strategic roadmap. We have to start with pilots and then go to the data and the machine level operations and then integrate it and bring it to scale. And then we should have a governance structure on the data and its utilization. So since I worked around 12 years in deep mining, and we tried to apply predictive maintenance to our operations, one of the things is sensor data. Like large steel mining operations, smelting operations, refining operations, processing operations have a lot of sensor data. Many of them are legacy sensors. So we will have to connect all these data to our monitoring system and have a database which is sanitized and clean. This is very important. So predictive maintenance helps us. With the help of predictive data and clean data, we can do a lot. And then what we did in the trucks, in the Corona truck, is that we had some edge to cloud analytics. That some of the analytics were done on the truck and the PLCs in the truck, computers in the truck, the electric truck, and then it connected with the cloud data, cloud server, and then we did the analytics, the NLP processings, the natural language processings, brought it back to the cloud, and then used on the truck real time. So, and we as I said, that I am working in light railway projects, infrastructure projects, very big projects, and they have autonomous trains. So, and it's similar to autonomous haulage. So we could use both the same technology, like how do we run trains automatically, safely, and how do you apply AI to these train operations. We are working with Alstom, a leader in this field, in the projects, and with here. So we were able to boost the productivity by around 10 to 15%, 10 to 20% in the Coleman mine. So basically what I was talking about, that edge cloud machine level operations architecture. So we have the sensor and equipment, we sanitize the data, capture the data, have some edge analytics, because these are very rough and tough environments that the trucks operated in the mine around 6,000 meters deep. So we have some edge analytics, so the whole 5G network and everything has to be configured. And then we transmit it to the cloud for data analysis, NLP processing, and bring it back to the machines. So this setup is very tough to replicate, and it has to be very robust. So the communication and the monitoring has to be very robust. So that's a challenge. Our legacy system used leaky feeders, but it couldn't work. So we had to create a 5G network in the mine, 6,000 meter deep, and have fiber optic communication to the surface, and then use these concepts of data analysis at the edge as well as at the cloud and the data lake and the machine level operations. And then send this data back to the mine and have a real-time operation on the trucks. Moving to steel making, like the same technologies could be used in EAF and BOF, optimizing. One thing can be optimized is the energy, the other thing is about the endpoints. The same thing with castings, like, in fact, again, Ms. Chatterjee's development, a product could have a good influence in that, is the prevention of defects and breakdowns. The cameras could really help it, and I will be talking about it a little bit. And and in rolling also predictive maintenance, AI inspection and inspection of the bearings and all that is all very helpful and to do. So in EF optimization in Algoma Steel here in Canada, which we are implementing, we are expecting an energy, and it has been shown by our research that energy can be reduced by AI, optimizing the parameters by 10%. The electrode consumption can be reduced by 15%, and tap to time would be reduced by 9%. This is from our research, and we hope to see this effect of AI in EAFs that we are being implemented. And then, as I said, the Vision AI monitors arcs and slack foam. Again, this could be an application of vision cameras and using AI to do that. And the other thing, I was talking about scrap a little bit earlier, like how to optimize the scrap mix and improve the consistency. That could be also an area where AI could operate in. So in BOF and ladle metallurgy, from our research, we see that the endpoint accuracy can be really improved. And as you know, the BF has a lot of parameters to monitor and optimize. And to do it without AI is a bit difficult. We were facing that when we were doing neural networks and trying to do POF optimization and predictive networks and digital twins. AI really helps to do that because its processing capabilities and its analyzing capabilities are very high. So basically, we could have targeted projects in terms of AI helping predict the ladle temperature, the alloying, and then before AI came through, we were using digital twins and trying to optimize and predictive. So digital twins could be used with AI to minimize reblows and hit losses. So going to the next slide. So again, another aspect of continuous casting and quality. So again, digital twins with the help of AI could anticipate defects. AI vision could inspect the surfaces in milliseconds, and it could really improve the quality and rework and reduce the rework and scrap that we have in terms of continuous casting and quality. In rolling mills and predictive analytics, one thing is predictive maintenance, because these rolling mills have a lot of motors, electric motors, bearings, and vibration is a big factor. And vibration is also applicable in compressors, generators, turbines, motors, and vibration analytics. Like previously, we used to have legacy systems. We used to work with Bentley Nevada systems. Now, when we put in AI and try to use it for vibration analytics, it really simplifies the whole work. And it really helps us to use it over a large database of equipment. And then the monitoring of temperatures, vibrations really helps in reducing the downtime and having predictive maintenance accordingly. And of course, AI has a very large capability in natural language processing, which helps in scheduling and optimizing throughput. So generative AI in operations, that is critical today in our field, the steel field and the mining field that we are working in. And the creation of knowledge networks and using natural language processing to help us optimize the knowledge networks and have greater granularity is very important. So how to find out the root causes of all the incidents and operational events that we have, and how to generate reports like a safety incident report or a root cause analysis report of a particular failure, and then do it over a large set of data. This really helps. Generative AI, we are using it, and it really helps. So the auto generation of reports, the training, and the root cause analysis. But the human factor is always there, but the AI helps the AI agents will help the humans in terms of better decisions, better analysis. So that's what we see. So the deployment, how do you deploy AI? So we have to find out, because the data set is so large, we have to have instrument critical failure modes, the critical instruments first. We have to secure the data and the streaming platforms, and then we have to create pilots, digital twins, validate them, integrate them, and then create machine level operations and data lakes to analyze. So it's the pilot, validate, edge cloud, edge computing, and then the data lake. So we have seen this, as we have said, that the economic effect is in terms of availability, failures, maintenance, yield, and energy. So this is from the research that we did to prepare this presentation, that we saw such improvements. So in conclusion, what we say is AI plus digital twins. Most steel plants have digital twins. Most mining systems have implemented, to a certain extent, digital twins. So if we could add AI to digital twins, we can improve higher uptime, yield, safety, etc. And this has been proven in Coleman Mine Valley, where I had the privilege to work, and across Valley, and it can certainly be, and I certainly know from my research that the steel plants are implementing digital twins. So will be a good idea to apply AI to the digital twins and use data, which is both from legacy and new, and sanitize and apply it. And so this should be aligned, of course, with the broader ESG and governance goals, and we should have an ROI of around 12 to 24 months. So now, taking a step back, how I came interested and to really use in this hard to decarbonize industries, AI, and how it will help. So as you know, hydrogen is being applied and is being used. Pilots are being taken into testing modes. And CO2 is a problem in blast furnace and steel making. So I tried to use AI to research and then implement these pilots and improvements where I could. And AI and its capabilities in terms of natural language processing and its other edge-to-cloud computing capabilities and its capability to handle a lot of data really helped. So as we know, like steel industry is 7% of global CO2, coke intensive, POF is coke intensive. Hydrogen can replace coke. Like we were playing with all these ideas, and then how to implement it and how to optimize it, and how to decrease the time in terms of project formulation and then pilot implementation. So in this also, AI has a big impact. So these are, from our research, we found that these are the areas where people have done and have published work in terms of Japan, Nippon Steel, Germany, ThyssenKrupp, India, Tata Steel, China, Baowu and Highcraft, and CO2 reduction in 400-meter blast furnaces. So this is from a research we found. And what we found is very interesting is, what is important here is not only the pilots and the AI, but also creation of knowledge networks. And this should be transnational, like it should be agnostic of the country or the area or the industry. So creation of knowledge networks, really AI and its NLP capabilities, natural language capabilities, really will help us a great deal. So again, like CO2 capture, we are writing projects and we are trying to implement pilots is that in terms of top gas recycling, oxygen plants. This is a big thing, like how much oxygen to inject and when to inject, and the carbon input, how much to give and how to control it. And then the world is talking about carbon capture. So carbon capture is a big area where a lot of investment and research will go in, and carbon capture can actually be optimized using AI. And we have seen steps taken by Arsenal Metal and US Steel in doing this. Now, this is something which is very close to my heart, which is the maintenance and electric trucks and infrastructure. As you know, like the world is moving towards electrification. So electrification is a big thing that's happening, and the change, it's a drastic change that's happening. So in terms of mining and logistics, AI gives a big improvement and moving maintenance from reactive to proactive and predictive. And we have done ourselves work in the Coleman Mines Corona Truck project, where we were able to increase availability, both without AI, using predictive maintenance, and then with AI and predictive maintenance. And then we see it being corroborated by Volvo's AI maintenance, which they have published, that they were able to reduce improve maintenance by around 20% and cut costs by 20%. So we tried in the mining operations in Canada, in northern Canada, which is large copper and nickel mines and precious metal mines. And we tried to apply root cause analysis, and we tried to use AI to help us do the root cause analysis. And then we took a pilot in the Corona trucks, and we tried to apply our knowledge and capabilities to the Corona trucks, and we were able to improve the availability by 27%, and the tonnage production as well as the haulage capabilities. So, as you know, the Corona truck is a battery electric as well as a trolley assist truck. And it works in very harsh environments, very rough environments, in underground mines, and very cold also. So we were able to give a higher uptime, which is critical to the mining operations and to the whole mining profitability. And both predictive analytics and AI really helped us in doing that. So this is something which we found from our research, that unplanned truck breakdowns are extremely costly. And a recent study that we researched said that 500 firms, the top 500 firms in terms of logistics, lose around $1.4 trillion annually to downtime, and which is around 11% of the revenue. So it's a big thing, like how we can reduce downtime. So we try to apply our research and go deep down into the whole scheme of things. We created a hierarchy of in the truck of the various components, which is illustrated in this presentation. And because to use AI, predictive analytics, digital twins, one of the first things we have to sanitize the data and make it very clean and uniform. So creating the hierarchy helped us doing that. So, and then, again, computer vision that I was saying is very important in terms of AI. Finding out the electrical hotspots and the tire and the propulsion hotspots is very important. So they can predict failures very high, very fast, and very before an incident happens. So predictive maintenance and computer vision is a very important aspect. And this we also applied in the light rail transit, the trains, in terms of the bearings and the propulsion systems. So we created, again, I'm talking about hierarchy in the slides. So for the electric truck, we created the hierarchy and sanitized the data and we created a database both in the cloud as well as in the edge to do our analytics and predictive maintenance. So to belabor the point, thermal imaging helps not only in mining, smelting, processing, refining, it also helps in maintenance for the wire, the defects in the brakes, the tires, the connectors, and the leak. And it really increases the inspection accuracy and speed. So one of the things that we use in electrical engineer, as an electrical engineer, is that thermal imaging detects overheating of cables and hydraulic leaks. This is a big thing if we can implement. So again, like the hierarchy, creation of the hierarchy is important. So we did that. And this is an example of a hierarchy of an electrical system of the transformers, the current collectors, the generators, the motors, the battery, and the controlling electronics. We could get some real world gains here. So we can see that we can reduce we are able to reduce the component failures in the electrical systems, the drives, the collectors, the transformers, the motors, and the midshift. That's one of the truck components. So again, we analyzed and cleaned up the data and created a uniform hierarchy. So we categorized the data in the various forms like the collectors and the drives and the brushes, etc. And then tried to derive knowledge from the data that we have and then use it to our benefit. So here, it's a very important thing that natural language processing really helped us in looking at the logs and the uniform report logs and the maintenance logs, and then trying to get insight out of it and trying to predict behavior of machines. So a maintenance weeks, so such a system then alerts the maintenance weeks in advance. This is what we found actually. And the other thing we found that we could find out a lot of hidden patterns in the data that we had, which was legacy data, and it was very time consuming to process it otherwise without the use of NLP. So basically what we did, again, this is a specific case that we were able to improve the availability, we were able to use the natural language processing, and we were able to push ability beyond around 90%. So benefits were higher ton mile, safety, cost. Safety is also a big thing, like incidents and failures reduced. And so this was a live project that we did. So this is the end of my presentation. So I'm open to any questions or any inputs, and I look forward to working with the august people that we have, the privileged people that we have in this conference to take things further. Thank you.
Thank you. Thank you, Sujit. This is Pritish here. Excellent presentation. From the permission of the chair, Sujit was very busy. He is under commissioning this Los Angeles project. He was telling me that to spare him this time. So I said, no, you have to do the presentation because you are like it. And also I that time mentioned if you could really tell that one which you are implementing, that hydrogen project, that your transportation system.
Yes, so this is the first hydrogen train in North America. It is replacing diesel locomotive units that transport people, like the light rail system and the diesel locomotive system there. So like in US, just like in India, we have the Federal Railroad Transportation System. So they have their own safety systems and own types of rules and regulations and specifications of the diesel locomotives. We are trying to, and the train systems, we are trying to convert this to hydrogen. So we worked with the German company Stadler and Alstom in two projects, like the Los Angeles airport project is with Alstom, and and Zimu train, the hydrogen train, is with Stadler. We worked with these companies to bring these capabilities to US. As you know, like just like Make in India, US has made in US preferences, and then adaptation of these technologies to the real world examples and real world train movements and passenger carrying. So we had to do a lot of work, and again, AI and natural language processing really helped us to do that work, because there's a lot of systems here where we have to analyze, check for safety, we have to do risk analysis, hazard analysis, so many things we got to do. And these are very structured systems. So normally these were not being done, and it's still not being done with the help of AI. But what we saw is that to use AI and to do these systems, it really helped us. Of course, you need knowledge networks. You need knowledge SMEs, subject matter experts, to act as agents and guide the whole process. But what we found is really helpful. And that's my take on things. Like AI can be a friend to us, but we have to have the knowledge, the deep domain knowledge, to help us and guide the agentic AI.
Thank you. Thank you, Sujit. You found out time out of your commissioning time. Now it is commissioning. You are very busy. Thank you very much. If there is any question from the audience, with the permission of the chair, people can ask.
Thank you. So, and you can always write to me or come through Pritish, like I can share all my knowledge with you, so that's not a problem at all. And we can work together. In fact, I am looking forward to coming to India and trying to see whether we can do a pilot in India, actually.
Yeah, you're saying you are coming in December, no? 9th December.
Yeah.
We'll make a visit to IIT, our old alma mater. Professor Das is also here. We can do something. Thank you. Thank you, Sujit.
Thank you.
Thank you, Mr. Sengupta. So it is really, you have touched different aspects of the predictive analysis and AI, particularly in electric, because my interest is in electric arc furnace and BOF. And in electric arc furnace, you have told using AI, the energy reduction will be there, electrode consumption will be reduced, and tap-to-tap time may be decreased. So can you highlight how tap-to-tap time can be decreased using AI?
Yeah, the basic thing is more optimization and prediction. So the first step is to create a digital twin of the AI, digital twin of the EF, the first step. Once we create the digital twin, we can use NLP to optimize the inputs and the outputs, and control the oxygen flow, the argon flow, and predict these flows with the end state in mind. And then also the scrap, how much scrap we put, how much, when to put, what is the temperature to maintain. So first is the creation of the digital twin, second is the optimization and prediction with the data that we have, and then feeding these inputs into the real-time optimizer. So this is the way we followed here in Canada.
Okay, thank you. Any more question? Any question from audience? Thank you. I think there is no question just at this point of time. Maybe if there is any question, they can write directly to you or through Mr. Kish. So
yes.
So
I will welcome that, actually. I will welcome that, and I'm ready to help. Okay, thank you for the time.
Thank you,
Thank you, Sujit. Thank to you. You got up early in the morning and also got 5 o'clock in the morning. Thank you so much, Sujit. Okay, bye.
Take care.
Bye.
Have a good day. Have a safe day.
And thank you. Let me thank Professor Rajiv De and the two speakers, excellent speakers, Riti and Sujit. I just request Mr. Chatterjee again to do an honor for them. Of course, Sujit, we have kept your gift with us. When you come, you can collect from me.
Sure, sure, sure.
Yeah.
Thank you.
Now, Riti, can I request Riti to come, please? And we'll stand here only, or no? Give it. Hey, Rajiv, Esho. Riti, madam, is here? Yeah. It will be honor for Mr. Chatterjee also to give it to you, taking it from Mr. Chatterjee. Yeah. A big round of applause. Yeah. Riti is suffering high fever. Even then, she could come. I mean, thank you very much, Riti. No, please. Thank you very much. Thank you. Thank you, Rajiv. And it's an excellent technical presentation we have just ended. We'll just have a small valedictory session. Thereafter, we can go. And good to see so many people around there.
Shown in her slide. This is the from our microcam, the picture of dolomite. The rhombohedral view. And lines. This is limestone. With proper lighting, we can differentiate between limestone and dolomite. Thank you.
We'll do the valedictory session. Yeah, just will take 10 minutes. And request Mr. Jayant Chatterjee, Mr. BP Sarkar, Mr. AK Sarkar. AK Sarkar has to leave. I think he is not there. Arnav Banerjee. Arnav?
Yeah. First of all, I would like to thanks everybody, but before that, I would like Mr. Vishnu Sarkar to BP Sarkar to speak something.
Good evening to everybody. You must have enjoyed the presentations by the very distinguished speakers. We have this, I think, 16 or 17th year continuously we have Steel Tech seminar, and it is attracting very knowledgeable experts from all over the India and sometimes abroad. So today also we had very good papers, especially inaugural session. We had giants like Devashri Bhattacharya, Jayanta Banerjee, and others. They have covered AI specifically very well, and we are all enriched by their presentation. And Mr. Arunava Banerjee of Primatals, he also given an excellent overview of the AI and other technology which Primatals has been giving. So we are really thankful to all the speakers who have come all the way and the participants who has made it a very successful one. So I'm sure this branch will continue to attract experts in our coming seminars also. So I think Pritish will talk about our next seminar.
Now over to Mr. Chatterjee.
Those who are following our series of seminars that we have been doing for last 3-4 years, you can see one thing, that there is a gradual improvement in the quality. This is a culmination of that same trend that we have maintained. As I was telling jokingly someone, that this seminar is different from the normal seminar of those commercial nature, where people sit outside and inside there is nobody, and the lecture is going on. So we would like to make it more and more people sit inside and nobody outside. That should be so interesting. And thank you very much for all your support, guidance, and which has taken us to this way. And I sincerely hope that it will continue like this. And others will be also coming and joining us. There is a lot of good remarks that we have received. We have all calculated it, put it in, collated it, and we will circulate it also. Thank you very much. Thanks a lot.
Thank you. Like they have seen me enough. Thank you very much. At this end, so many people are there from places, particularly Prime Metals, Fabes, and also Tenova and other delegates. Thank you very much for staying, and I hope you have enjoyed the seminar. A lot of work being done by the team, and also the lot of support given by our sponsors and our well-wishers. And I must thank Meeta for tolerating me last few days at least, because she was always used to come, it is already late, you must go to sleep. So I said, you don't worry. And I am fortunate that we have two flats together one side. So I prefer to stay in the flat in the south side where I work, and she stays in the north side. Morning 1 o'clock she'll get up. I'm not there in the bed. She'll come to south block and again tell me. I said, you go to sleep. Then after I'm coming. Again she'll come at around maybe 2:30 in the morning. But thank you for tolerating me. And thank you everybody for the great support. These sort of seminars, for doing it, it takes a lot of networking, a lot of support, a lot of guidance. And thank you very much, all these sponsors, all these people. I think Arnav will mention that in detail. And I sincerely thank you, and Arnav will cover a bit. And this is the probably first time we are going to have another special seminar on C4, that we call C4. That is because coal, coke and coal chemicals. That we are going to have it on 21st of November, 2025. 21st of November, that's a Friday, at Bhubaneswar, ITC Bhubaneswar. We'll circulate. The people who are interested may also kindly join from this group. There is a big group there in Bhubaneswar, IMMT and other research people, they are coming, some CGFI, so they are coming. So I request all of you, those who are interested and have interest in this C4, we'll circulate Arnav will circulate that the brochure. So thank you once again. Yeah, love to Arnav.
Before giving it to you, I'm just again requesting, we have got feedback form, and even if you want to give further any feedback to us or those who have not given, you can always write to Pritish Sen in his email or WhatsApp message, and so that we can improve in our next seminars and conferences. So feedback is very important for us.
Now it's the time to give you formal vote of thanks. First of all, I thank all the participants who have joined this seminar to make it a great success. Thank you everyone for being here, and especially being here till now 5 o'clock in the evening. We thank to all sponsors. Without their support, it would not have been possible to conduct such a great event. We thank the hotel management, Taj Bengal management, for allowing us to host, utilize this hall, and for the very good lunch they served. Our special thanks goes to Anandam Events and Mr. Shubhajit Ghosh, who was our partner, infrastructure partner, for making all the arrangements in this hall. Thank you. This is the first time we offered them this contract, and they did it very well. We are thankful to them. And last but not the least, thanks to the speakers whose excellent deliberation have helped us in making this event so successful. Thank you everyone. Our next seminar Yeah, our next seminar, as mentioned by Mr. Sen, on 21st November at Bhubaneswar, and followed by again next April, what we do every year on ferroalloys, and next September again on steel. We will let you know the schedule and subject in due course of time. But whoever is interested, who can attend the seminar, forthcoming seminar on 21st November at Bhubaneswar. See you there at Bhubaneswar. We'll send the brochure to everyone who have attended this seminar and whose email addresses are available with us. We will send them the intimation to attend the event in Bhubaneswar and make it successful. Thank you very much. Once again, we are having tea and snacks outside. Please have before you go home. Now, let's have a group photograph. Please come and have a. আসুন আসুন এদিকে আসুন